Hello everyone, thanks for chiming in. I am here today to teach you the quadratic formula. Quadratic formula is something that we use to find the solutions of a quadratic. Solutions also having some other names known as roots, zeros, or x-intercepts. I'm going to show you the formula first with one that is actually factorable that has very simple roots, just so that we can get the point of it. And then I'm going to show you two more, each getting a little bit harder. So please bear with me. The quadratic formula is here. It states x is equal to negative b plus or minus the square root of this whole thing, b squared minus 4 times a times c, all divided by 2 times a. Now you might be wondering where that a, b, and c is coming from. But if you remember, when we put quadratics into standard form, highest exponent to lowest, you have your a term would be the first one with the squared, your b term is the middle with the x, and your c is always the constant, the last term. Okay, so using this quadratic, I'm going to find my a, b, and c, plug it into the quadratic formula, and find out what my roots are. So a in this case, the coefficient, there is none there, so I know that it's 1. B is negative 5, and c is positive 6. So if I use these numbers in the quadratic formula, I would get x equal to, I have negative b, so I'm going to write negative, and I'm going to put in parentheses so I don't mess up with my negatives. My b term, negative 5, plus or minus the square root of b squared, so that's negative 5 squared, minus 4 times the a term, 1, times the c term, positive 6, all divided by 2 times that a term again, 1. So now, you could put this in your calculator, but it might get a little bit crazy. So I'm just going to do the math in my head for myself. Negative 5 times negative 5, or a negative times negative 5 is going to bring me to a positive. Then I have plus or minus still, square root. Negative 5 squared is 25, minus 4 times 1 is 4, times 4 is 24. Okay, and that whole thing over 2 times 1, which is 2. And now I can work this out. 25 minus 24 is going to give me 1. So I have x equal to 5 plus or minus the square root of 1 all over 2. And the square root of 1 is 1, so we have x equal to 5 plus or minus 1 over 2. Now, when you have a plus or a minus, that means it's one or the other, so you're going to have to split it up. So that means we're going to have x equal to 5 plus 1 over 2, or x equal to 5 minus 1 over 2. Hope you can get that on the screen. A little short. There we go. Okay, and if you work that out, 5 plus 1 is 6 over 2. So this one would become x equals 3. And 5 minus 1 would be 4 divided by 2. So it's going to be x equal 2. Okay, so x equals 3 or x equals 2. That means that this quadratic or parabola crosses the x-axis at 3 and at 2. Okay, so that's an easy one. This one would have been factorable. We could have figured out that the factors of positive 6 that add to negative 5 would have been negative 2 times negative 3. And then if we set them equal to 0 and do our ZPP, it would have ended up x equals 2 and x equals 3, which is what we got there. Okay, but sometimes these things are not factorable, which is where the quadratic formula comes in and is necessary. So let's say we have something that looks like this. Second example, okay? We have x squared, 4x squared minus 5x plus 1. Okay? Now, If I factor this, I would have to do that reverse box method thing. It would all get a little bit crazy because you have 4 times 1 that you have to start with. So instead, we're going to find the solutions or the roots or the zeros or the x-intercepts by using our quadratic formula. So the first thing we need to do is figure out what a is, in this case 4, what b is, -5, and what c is, 1. So we can plug it into the formula. X equals negative. Instead of b, I'm writing -5 plus or minus the square root of b squared minus 4 times your a term, 4 times your c term, 1, all over 2 times that a term, 4. Okay? Now we're just going to do some math over here. So I have x equal to negative times -5 becomes +5, plus or minus, and then the square root of -5 squared is 25, minus 4 times 4 is 16, times 1 is still 16. So 25 minus 16 is going to give me 9. All over 2 times 4 is 8. Well, lucky us, 9 is a perfect square. So this breaks down to 5 plus or minus, square root of 9 is 3, all over 8. Which means we're going to have 5 plus 3 over 8. And we're going to have 5 minus 3 over 8. 5 plus 3, 6, 7, 8 is 8 over 8. So this one's going to be x equals 1. 5 minus 3 is 2. And 2 over 8 broken down is 1/4. So for that one, we have x equals 1 or x equals 1/4. So if you see, if we factored that, it would have got a little bit messy because we ended up with a fraction, but it is doable. The next one, not factorable at all. So this one, not as easy as the first one, but still showing you how to use that quadratic formula. And now it's going to get crazy on us. Okay, let's say we have this time a sad quadratic. What makes a quadratic sad? Yes, it goes upside down like a sad face, but it has a negative in front. So this is going to be negative x squared minus 8x plus 2. So this time when I have a, it's going to be -1. B is going to be -8, and my constant there is a 2, my c term. All right, so filling that into our quadratic formula, x equals -b, which is -8, plus or minus the square root of b squared minus 4 times a times c. See, a -1, c -2. I'm plugging it into here. All over 2 times a -1. Now I'm going to work this math out over here first. -8 times -8 is going to give me 64. Minus 4 times -1 is -4. Times 2 is -8. So that's a minus. 64 minus -8 becomes plus. This will give us 72 for our radical. And coming back around, negative times -8 gives me +8, plus or minus. Now I already did this math over here, so I have square root of 72. All over 2 times -1 is -2. Now, 72 is not a perfect square. Before, we had 9, which was a perfect square, so we just take it out. That's not the case here. 72 is not a perfect square. I don't know how to find the square root of 72. But if I think back to the very beginning of algebra, this is the reason why we learned that. Do you remember what I'm talking about? What did we learn about radicals what was the point of this existence? Here it is. Finding the solutions of a quadratic. So we're breaking down the square root of 72. Well, 72 is not a perfect square, but I do know of a large perfect square that it can be divided by, which is 36. 36 times 2 is 72. And the square root of 36 is 6 radical 2. That's in simplest form. This is the whole reason why we did this. Now we're going to replace this. X equals 8 plus or minus, instead of 72, I'm putting 6 radical 2 all over negative 2. Now, depending on what the question asks you, you might be able to put this in your calculator and get a decimal as your response. They might ask for your response in simplest radical form. If they ask for simplest radical form, that means this could either be it, or can we simplify further? So I'm going to erase. Yes, I'm using a fabric softener as my eraser. I'm going to erase this for the sake of more room. And I'm going to rewrite this. Okay, x equals 8 plus or minus 6 square root 2 all over negative 2. I'm going to rewrite this so that I can show you that this can be simplified. I can divide 8 by 2, I can divide 6 by 2, or negative 2 in this case. So if I do that, I have x equals 8 divided by negative 2 is negative 4, and 6 divided by negative 2, so plus or minus negative 3 radical 2, and then this cancels. So now I'm left with this to split up. X equals negative 4 plus, this is why we split it up, negative 3 radical 2, or x is equal to negative 4 minus negative 3 radical 2. And that, ladies and gentlemen, is why we use the quadratic formula, because this is completely not factorable. So all those ones that we thought had no solution when we were factoring actually do have solutions. They're just at random, crazy places that we can't actually point out unless we do it this way. Okay? So those would be your two answers. You could, of course, simplify your plus and minus here. Like plus minus is the same thing as just take away. And over here, minus minus, same thing as plus. Really doesn't make a difference. But that is a quadratic formula in a nutshell. If you need more help on it, let us know. I will find some more problems to do for you. But I hope you get it. Take a picture of this, write it down, note it, because you're going to need it. All right, see you soon. Good luck.